Namaste class, module 2, name of the chapter is applications of derivatives. In the previous module, we have discussed increasing and decreasing functions. Today, we are going to discuss more about tangents and normals. Before moving on to the topic, that is tangents and normals, we are going to discuss some of the important concepts you have learned in grade 11. That is, whenever two lines are parallel, their slopes are equal. M1 is equal to M2. If two lines are perpendicular, then product of their slopes is -1. M1 into M2 is equal to -1. The slope of a line which is perpendicular to the line having slope M is -1 by M. The slope of a line AX plus BY plus C equal to 0 is minus A by B, that is minus of coefficient of X upon coefficient of Y. And these are the concept very much useful to learn tangents and normals. Tangent. What is a tangent? Of course, it is a line which intersects given curve y is equal to f of x exactly at one point. Assume that the function y is equal to f of x, and this may be the graph of the function. Now, for this graph, we have to draw a line which intersect the given graph exactly at one point. Here, L is the line which intersect the given curve exactly at the point P. Therefore, P is the point of contact of the tangent line L. Assume that the coordinates of the point P is x1, y1, and the line L makes an angle theta with the positive direction of x-axis. As per the definition of slope of a line is tangent of the angle made by the line with the positive direction of x-axis. Therefore, M is the slope of the line L. Now, x1, y1 is the point of contact of the tangent line to the curve. Now the line L passing through the point x1, y1 having the slope M. We can find the equation of the tangent by slope point formula. Y minus y1 is equal to M into x minus x1. So which is the equation of a tangent line at the point x1, y1 having the slope M. Normal. What is normal? Normal is also a line. Let me explain through this graph of the curve y is equal to f of x. Draw a tangent line to the given curve y is equal to f of x. The tangent line intersects the given curve exactly at one point, that is P, whose coordinates will be x1, y1. Yes, of course, for this tangent line, we can draw infinite number of perpendicular lines. Out of these perpendicular lines, only one line is passing through the point of contact. That line will be the normal line. So normal line is a line which is perpendicular to the tangent through the point of contact. Now the slope of the tangent line will be M. The normal line is perpendicular to the tangent line. Therefore, slope of the normal line is -1 by M. Now the normal line having the slope -1 by M passing through the point P of x1, y1. Therefore, according to the slope point formula, The equation of the normal will be y minus y1 is equal to minus 1 by m into x minus x1, which is the equation of a normal at the point x1 comma y1. Important results we are going to discuss. Let us consider the curve y is equal to f of x, and this could be the graph of the curve y is equal to f of x. Now draw a tangent line to the given curve. Now the tangent line intersects the given curve exactly at one point P. Assume that the line L, that is the tangent line, is parallel to the x-axis. Whenever a line is parallel to the x-axis, the angle made by the tangent line with the positive direction of x-axis is 0. Therefore, slope of the tangent line will be dy by dx equal to tan of 0 degree, which is equal to 0. So, therefore, whenever the tangent line is parallel to the x-axis, then dy by dx is equal to 0. Result 2. Consider the graph of the curve y is equal to f of x. Draw a tangent line to the given curve y is equal to f of x. Assume that the tangent line is parallel to the y-axis. If the tangent line is parallel to the y-axis, definitely it is perpendicular to the x-axis. Anyway, to find the slope of any line, we need the angle made by the line with the positive direction of x-axis. So therefore, the line is parallel to y-axis. It is perpendicular to the x-axis. Here the angle made by the line is 90 degree. So the angle made by the line with the positive direction of x-axis, then slope of the tangent line will be dy by dx is equal to tan of 90 degree. Tan 90 degree is not defined, therefore infinity. If dy by dx is equal to infinity, therefore dx by dy is equal to 1 by infinity. In 1 by infinity is 0. Therefore dx by dy is equal to 0. So this is the condition. Dx by dy is equal to 0 when the tangent line is either parallel to the y-axis or perpendicular to the x-axis. Through an example, let me explain one of the concepts which we have learned in this module. Find the points on the curve y is equal to x cube minus 3 times of x squared minus 9x plus 7, at which tangent is parallel to the x-axis. To find the points on the given curve at which the tangents are parallel to the x-axis, we need to find the first derivative of the function y is equal to x cube minus 3 times of x squared minus 9 times of x plus 7. So differentiation with respect to x of the function y become dy by dx, that is first derivative of the curve y is equal to x cube minus 3x square minus 9x plus 7 is 3 times of x square minus 6 times of x minus 9. Take 3 as a common factor, so x square minus 2x minus 3, and factorization of this quadratic equation will be x minus 3 into x plus 1. Now since tangent is parallel to x-axis, so the condition when the tangent is parallel to the x-axis is dy by dx is equal to 0. That is x is equal to 3 and x is equal to minus 1. When we equate this factors x minus 3 into x plus 1, we may get x is equal to 3 and x is equal to minus 1. Now let us take the equation number 1. Y is equal to x cube minus 3 times of x square minus 9x plus 7. Substitute x is equal to 3. Therefore, y is equal to 27 minus 27 minus 27 plus 7, which is equal to minus 20. Similarly, substitute x equal to minus 1. Y is equal to minus 1 the whole cube minus 1 minus 1 the whole square plus 1. 1 into minus 3 minus 3 9 minus 9 into minus 1 plus 9 plus 7. So therefore, we may get y is equal to minus 12. Therefore, the required points are when x is equal to 3, y is minus 20, and when x is equal to minus 1, y is minus 12, at which the tangent is parallel to the x-axis. Find the equation of the tangent to the curve y is equal to x square minus 2x plus 7, at which tangent is perpendicular to the given line 5y minus 15x equal to 13. To find the equation of the tangent, we need point at which the tangent is drawn to the given curve and slope of the tangent line. So firstly, take y is equal to x square minus 2x plus 7. Find the first derivative, that is dy by dx. Therefore, 2x minus 2. This is the slope of the tangent, denoted by m. Now the given line is 5y minus 15x equal to 13. Slope of any line is of the form ax plus by plus c equal to 0 is minus of coefficient of a divided by coefficient of x divided by coefficient of y. So therefore, slope of given line is equal to minus of coefficient of x minus 15, coefficient of y 5 become 3. Since tangent line is perpendicular to a given line, whenever two lines are perpendicular, product of their slopes is equal to minus 1. That is, slope of the tangent into slope of the given line is equal to minus 1. Therefore, m is equal to minus 1 by 3. So this is the slope of the tangent line. Even here m is given 2x minus 2. So 2x minus 2 is equal to minus 1 by 3. Therefore 2x is equal to minus 1 by 3 plus 2. Therefore x is equal to 5 divided by 6. Now let us take the given equation y is equal to x square minus 2 times of x plus 7. Substitute x is equal to 5 by 6. Therefore, y is equal to 5 by 6 the whole square, 25 divided by 36 minus 2 into 5 by 6, that is 10 divided by 6 plus 7. Therefore, y is equal to, let us take 36 is the LCM, 25 minus 60 plus 252. After simplification, we may get y is equal to 217 divided by 36. Therefore, the point of contact of the tangent to the given curve is 5 divided by 6, comma 217 divided by 36. So we have the point of contact of the tangent and slope of the tangent. So therefore equation of tangent is y minus y1 is equal to m into x minus x1. So y minus 217 divided by 36 is equal to minus 1 by 3 into x minus 5 by 6. So after simplification, we may get the equation of the tangent will be 12x plus 36y minus 227 is equal to 0. Today we have discussed equations of tangents and normals, and we have learned condition for tangents which are parallel to either x-axis or y-axis. Namaste. Thank you, children.